Hello and welcome to part 2 of this Autodesk Fusion 360 5-axis machining tutorial. We looked at this first part of the machining of the mid-housing in the last video, and this video will be completing the machining of the mid-housing. So if you're changing fixtures midway through your machining, or if you need to change your fixtures for another reason, just import it like another component. Select it as your fixture in your setup, and just make sure you have it aligned like I'm doing here. You have all your different types of motions here, you can see. And one thing you need to make sure is that it's aligned and right up against the surface of your component that you're looking to be machined, because that's the way it is going to be whenever it's being machined. So that looks good. You can see here the 3 holes all lined up. Now, I've left the original fixture in here, so we can just hide this, and we will be getting collisions with that original fixture. We can ignore them because we know that that won't be there for the second part of the machining process. So the first thing we're going to do here is adaptive clearing, and we're going to use a flat end mill. We're going to go with 10mm diameter, 40mm flute length. We're going to use rest machining machine cusps, making sure the tool orientation this time doesn't need flip because we're machining the other side of the component. See, it's the right side there. Your origin again, and then your heights. So we have machined most of this already, so there's not a lot of rest machining to be done after a certain height. So we can just go ahead, make sure all these options are okay. And you can see the tool path has been generated now. So this one takes slightly longer to program the machine to generate the tool path, and that will probably be reflected in the machining time for this process. So we simulate this through, and you can see already there's a lot of collisions. Remember, a lot of that will be with the original fixture, which won't be there for this machining process. So you can see even with that adaptive clearing, the component's starting to take shape now. Yeah, so if we look at these collisions, the tool collides with the fixture. However, it's not low enough to collide with the second fixture, so we know that that's the first one, the original, from the first machining operation, or the first setup. So we can't ignore that. It's just making sure that there's no collisions with this second fixture. So next, what we're going to do then is a 3D pencil mill, and we're going to select our tool, ball end mill, and we're going to use the 5mm corner radius, 10mm diameter bit. And we're going to do bounding box, center on bounding box, machine cusps, rest machining, And with faces selected here, this is just all the 5mm fillets. So it can machine all of these in one operation. It will be slightly longer, but it saves time in the long run. So we use the avoid touch surfaces feature for this. So I'm just going to select a few additional faces, so I'll speed this up and I'll be back after it. Okay, so once you're happy, click OK. It's going to generate the toolpath and hopefully machine all of those fillets. Obviously, the more faces you have selected, the more machine it has to do and the longer it will take to generate, so just bear that in mind. So here you can see our toolpath has been generated. So if we move on now to horizontal mill, 3D horizontal mill, and again we're going to use a flat end mill. And this time we're going to go for a 4mm diameter flat end mill. We're going to use bounding box, inside boundary, no additional offset. Again, ensuring your tool is at the right orientation. So if we click OK here, now you can see it's machined all of the flat areas on the back of our component. So and the collisions along the bottom again, colliding with the original fixture from the first setup. So obviously this machining process is taking a lot longer due to the smaller drill bit and the areas it has to machine. However, the steeper areas, it has to be that thin, the drill bit has to be that thin to reach those areas, otherwise it would be colliding with our component. So if we just check these collisions, you can see that the tool isn't plunging down, it's just colliding with the original fixture from the first setup. So if we move on now, then we're going to do a 3D contour. For this we're going to use a ball end mill, and we're going to go for a larger diameter. We're going to go for 24mm diameter. So then I'm going to use machining boundary bounding box. We're going to turn rest machining on, machine cusps, and then we're going to use the avoid touch surfaces, and we're going to select just these outside radii, outside fillets, so we can machine these because these are larger than the rest of the fillets on the component. So the heights won't really matter because it's just going to machine those features that we've selected. So we can move the heights anyway to suit the geometries we've selected or the faces we've selected. So once you're happy with everything else, go ahead and generate the toolpath. So you can see even from the toolpath that it's machining the right areas, so that's what we're looking for. And if we simulate this through, you can see there's a lot of collisions here, but I think all of it, or the majority of it anyway, is from the original fixture, from the original setup, first setup. So just watching the simulation here. So the machining the fillets in Fusion 360 seems to take a lot longer even in simulation. So that looks good, and now if we move on to another 3D contour, and we'll change our tool here. Again, we're going to use a ball end mill, and we're going to use a 12 mil corner radius, 24 mil diameter. All the same size, so it's orientated the right way. We're going to use bounding box as a machining boundary, and we're going to use 2 inside boundary, rest machining machine cusps. And then again, we're going to use this touch surfaces feature to select our faces. So again, this is for different size fillet. For a 12 mil radius fillet. That's why we've selected the drill bit. So again, making sure all of your settings are right for this machining operation. Your heights won't matter too much because you selected the faces that you want machined. So we select the just above and below the fillet that we're looking machined. And then once you're happy with all the rest of your settings, go ahead and click OK. Start generating the toolpath. So you can see here the toolpath's been generated along with the resultant stock, and it has machined this fillet along the edge here. So that's what we're looking, but we need another contour there for the other fillet, the remaining fillet. So if we go back into 3D contour and change our tool, and if this time we use a ball end mill with a 10 mil corner radius, so 20 mil diameter, and again we're going to use bounding box inside boundary, rest machining on machine cusps. And again, we're going to use this touch surfaces feature. We're just going to select the two faces that we want machined. And our heights again. And then once you're happy with the rest of your settings, making sure your step down is correct. Yeah, you can see along the bottom there's a lot of collisions. Hopefully that's with the original setup stock. You don't have to worry about. So you can see in the simulation, it's machining the correct surface and it's leaving a good finish on the fillet. So what we're going to do next is we're going to go 3D flow. And we're going to use a ball end mill. And we're going to go for a 5 mil corner radius, 10 mil diameter bit. Geometry, we're just going to select certain faces that we want machined, and again you see these arrows that appear whenever you click on the face. You can click the arrow to reorientate what way you want it machined. So whether you want it machined at left and right, or you want it machined up and down. So I've select these accordingly. So once you've all your faces selected, you can move on. Select your number of step overs. Remember, this is going to be for all of the faces you selected, so even the small faces are going to have the same number of step overs. This also has multi-axis tilting. So the flow takes slightly longer to generate toolpath than the contour. So you can see the toolpath starting to generate here, and it looks good. You can see the resultant stock has been generated, and the flow actually gives a better finish on curved edges than the contour operation. So if we move on then, we're going to go for another 3D flow. And we're going to use another ball end mill. We're going to use the 2 mil diameter, 1 millimeter corner radius bit. And then we're just going to select our faces here. So once you're happy with all the faces that you've selected, go ahead and specify your number of step overs. You can use multi-axis tilting if you wish. It also has maximum segment length, and then in your linking you have maximum stay down distance, which you can also change. So once you're happy with all your settings, go ahead and click OK, start generating toolpath. Okay, so we have a warning here. One or more passes were partially skipped. Okay, so that's not that big of an issue. We can simulate it through here. That's just happened so that it avoided machining an area on the component that we didn't want machined. So if we look at it here, that's okay. So if we move on, 3D flow, and we select our tool, ball end mill again, we're going to go 2 mil diameter, 1 mil corner radius. And again, we're just going to select our geometries here, the faces we want to machine. So once you're happy with the faces you've selected again, specifying your number of step overs, your multi-axis tilting, and the other features you wish to add. So once you're happy with all your settings, go ahead and click OK, start generating the toolpath again. So there you can see we have another warning. Again, one or more passes were partially skipped. So we don't have to worry too much about that. It's just automatically putting a pass in to avoid machining an area of the component we don't want machined. So next we're going to go 3D flow again. And we're going to select our tool here. We're going to go milling, ball end mill. We're going to use 2 mil diameter, 1 mil corner radius again. And again, we're just going to select our faces, the appropriate ones we want machined. So once you've selected all your faces, you want to choose your appropriate heights, specify your number of step overs, again your multi-axis tilting if you want. Again, your linking, your leads and transitions. And then once you're happy, click OK. So you can see the toolpath is being generated here. Now the resultant stock has been generated, so if we simulate this through, so you collision right at the very start, and you can see here it's colliding with our component rather than the fixture. So if we go into the flow here, edit, and the first thing we're going to do is specify our tool orientation. And then we also you could reduce your multi-axis tilting maximum tilt in degrees. So you could reduce this to 90 or 45, but we'll turn it off for now and run this again. And the Fusion 360 takes a lot longer to generate the tool path when you have multi-axis tilting turned on. So if we simulate this through again, we look at the collisions here. That's colliding with the original fixture rather than our component. You can see that's leaving a good finish on that surface, and it's machining those fillets well. So next what we're going to do is another flow, 3D flow, and we'll select our tool here. So we're going to go for a ball end mill, and again 2 mil diameter, 1 mil corner radius. And if we then select our faces that we want machined again, so once you've selected all the faces that we want machined, we specify our tool orientation. And then make sure you have the correct number of step overs. You can also specify the maximum stay down distance. Again, you can change your lead in radiuses and change your transition type if you want. So go ahead and click OK once you're happy with your settings. Okay, so you can see the toolpath starting to be generated here. And we're just machining the chamfers along the edges of these pockets around the outside of the mid housing. And the resultant stock has been generated. Looks good, looks like it's machined those well. That's a good finish. So what we're going to do next is another 3D flow. I'm just taking his time here. So again, selecting our tool first. So we're going to go milling, ball end mill. Again, 2 mil diameter, 1 mil corner radius. And again, selecting our faces, and we're going to select this chamfer just on the inside of this pocket. You could do all of the chamfers at once with the same tool, well, as long as the chamfers are the same size. But you can see here you have to orientate the arrows as to what way you want it machined. And if you specify your number of step overs, that number of step overs is the case for all of those small faces. So if you have some bigger faces and some smaller faces, they're all going to have the same step over. So sometimes it's better just to split them up into more than one machining operation. So once you've selected all your faces, make sure your orientation is correct. And again, specifying your step overs. Of course, the more step overs you have, the longer the operation is going to take. So once you're happy with all your settings for the operation, go ahead and click OK. So there you can see the resultant stock has been generated. And it hasn't left the best finish here on the edge on this chamfer. So if we go back in to the flow and we go change the direction of these arrows, so you could try changing the machining direction, or you could change your number of step overs. So we'll try that. Change it to 10 and then regenerate the toolpath, regenerate the resultant stock. So there the resultant stock's been generated, and you can still see we have these lines on the chamfer. So if we go back into and edit the flow, and we change the number of step overs to 20, and we change direction to one way, we see if this gives us a better surface finish. So if we have a close look here, that looks a bit better than what we had originally. It's definitely smoother. So we're happy with that. So what we're going to do next is we're going to go 3D contour, and we're going to use a flat end mill with 10 mil diameter. And then we're going to use machine boundary silhouette, tool center on boundary. We're going to leave rest machining on, and we're not going to use this avoid touch surfaces feature this time. We're going to use contact point boundary as well. Again, making sure your heights are correct, and then select OK once you're happy. And This is just a contour right around the outside of our mid housing. And now our toolpath is being generated, and it looks good. So next what we're going to do is we're going to drill this large hole inside. So you can see here all the different options there is in Fusion 360. So we're going to go for our standard drill, and you can input your own parameters and your own specifications for drill bits. So I'm just going to input here the drill bit. What's the correct size for drilling the side in this mid housing. So you can see here that the drill bit's been added to the list, so we can select that now and then move on with the rest of our settings. So you can see this is the part we want to drill, and you need to select your orientation again, and our heights. Heights are more important for drilling holes because you need to make sure that your hole is drilled right the way through. So once you're happy with your setup, go ahead and hit OK and start generating toolpath. And there you can see that operation has been generated and looks good. So next what we want to do is machine these holes in the side of the top of the mid housing. So you can see that the area that needs to be machined and the material that needs to come out. So if we inspect this, you can see the length of it and the distance we have to machine. So what we're going to use for this operation is another flow, because then it machines right around the outsides and gives a flat bottom to the hole. So if we select our tool here, we're going to use a flat end mill, and we're going to use a suitable sized tool as well for the operation. So if we select here the 6mm bit, sorry, the 10mm diameter bit, and the important part here is you getting your orientation correct. So what you want to do is select a face, and you can see the tool there is orientated in the right direction, in the right plane. So then just selecting your heights, you can select your top edge here, your bottom edge as the top height, so as the top of the hole. You can see it takes the very furthest point. That's exactly what we're looking there. And then for the bottom height, if we select this face, that's as far as we want to machine that hole. So once you're happy with all of the rest of your settings, remember your step overs as well. You can go ahead and click OK whenever you're happy. And you can see here that's successfully machined the inside of that hole. So if we use a 3D flow again for the other side, and we select the inside surface, select our orientation, and then again selecting your heights. Once you've specified your step overs and you're happy with the rest of your settings, go ahead and click OK. And you can see the resultant stock has been generated too. So if we inspect the longer holes on the inside here, we can see the length and the diameter of them, so we know what tool to use. So then for these, we're going to use the drilling process, the drilling operation, because we're drilling right the way through. So we just select our tool here, high carbon steel 8.4mm. So what we need to do now is, if we orientate our tool first, it's easier to select the surfaces that you want drilled, the holes that you want drilled, and then again selecting your heights. And you can see you might need to add some onto the bottom height for it to drill straight through. So you need to bear that in mind when you are setting up one of these operations. So when you're happy with your setup, hit OK, and then you can see here the toolpath has been generated along with the resultant stock, and that looks good. So we just repeat that process on the other side. So drilling operation again, using the same tool as the last time, so 8.4mm diameter. Again, selecting your orientation first makes it easier to select the hole that you want drilled. And then making sure your heights are correct. You can see here it's drilling right the way through the hole. So we'll go ahead and click OK. There, the resultant stock has been generated. So if we zoom in here, you can see on the edges that we need to machine that off. So if we select the flow again, and then we select our tool here, go for a ball end mill, 2mm diameter, 1mm corner radius, and if we just select these faces that we want to machine, just as the rough edges on it, so we can select there, and we select this side as well. And then your tool orientation, you want to be coming at it from one side. And then your heights. And again, specifying your number of step overs. Because this is the two faces of machine on both sides are different sizes and different shapes, you will need more step overs for a better finish. So whenever you're happy with your settings, you click OK. And that is the last machining operation for this engine mid-housing. and it's looking good. Everything's been programmed successfully. So that concludes the tutorial for Autodesk Fusion 360. I hope you've enjoyed the videos. In these videos, it's not the most efficient way to machine the component. They're made for demonstrative purposes to show you different ways of machining different geometries. And if you liked the tutorial, I've also recorded a tutorial on the Hypermill software on machining the same complex part